Welcome to Computer Science 4303. I'm really excited to have everyone here. My name is David Churchill. I'm an associate professor at Memorial University in the Computer Science Department. And this course is Artificial Intelligence for Computer Games. It's the second time that it's been offered and the second time that I've been teaching it. So hopefully this course goes a little smoother than last time. The last time it was offered was last winter, and it was interrupted ever so rudely by COVID-19. So hopefully we can actually finish the course this time instead of sort of cutting it short halfway through. I see a bunch of people out in the chat there. So just a quick note for anyone who is watching this on YouTube or on the downloaded video. These lectures are going to be, is currently being, and will for the entire term be live streamed online. Currently, I'm streaming this lecture live on my Twitch channel, and if the ads don't prove to be a real annoyance going forward, we'll stay on Twitch, but we may be moving to YouTube live streaming if the ads continue to be a nuisance. After each lecture, within a couple of hours, the lectures will be posted to YouTube and they'll be available for download on the course website. So again, welcome everyone to the course. It's completely free for the public to watch these lectures and on the YouTube channel. But the public will not have access to any of the assignment files or the lecture PowerPoint slides. So that's the only restriction, is that the course content, like the lectures, are available to the public, but the assignments won't be. And the reason for that is pretty simple. It's just that the assignments take a super long time to make, and if I release them to the public, then the solutions will be everywhere, and then I'll have to make new ones, and that's just not something that I can keep doing every year going forward. So you're free to follow along with all the lectures and learn as much as you want. You just won't be able to do the assignments. Okay, so I hope everyone had a good Christmas break. It was nice to get a little bit of a break from that term. Last term was pretty new for everyone, taking university online for the first time. Getting used to that. I felt really bad for the first year students who had to take their first year of university online. That must have been really brutal. This is a senior level computer science course, and so I guess it wasn't so bad for us computer nerds who are sort of used to living online anyway. So just a quick note about the setup here. If you see me constantly looking over to the side like this is me looking at the Twitch chat. So I'm trying to monitor Twitch chat for questions throughout the lecture, etc., which I've gotten used to now over the last 4 months of live streaming lectures. The reason I'm not looking straight at the camera is because I'm usually looking at the monitor, right? And so my camera is just above the monitor, and it's a little bit awkward to always be looking above and not being able to see the content. And so my webcam is usually smaller than it is now on the screen, but I just made it a little bit bigger just to do the introduction to the course. All right, so let's talk about what this course is about. So first I'm going to go over the syllabus to the course, and then I'm going to go into the first lecture slide. So we do have a lecture today. It's not going to be tested or anything, but the lecture is going to be sort of an introduction to what the course is, what is artificial intelligence, what is game AI, which I'll get into later. But first, let's talk about the course itself, how it's going to be run, and all that sort of stuff. So if you did either course with me last year, just type a 1 in the, type 3200 in the chat if you did 3200 with me, type 4300 if you did 4300 with me, or type both if you did both with me. I just want to get kind of a feel for who's out there who did courses with me last term. Specifically, okay, so that's cool. So we've got a lot of repeat offenders in the class. So a bunch of people did both. Some people did 3200, some people, okay, that's cool. So a lot of people out there have done both courses with me. This will be run almost identically to Computer Science 4300, okay? In terms of how the lectures are given, how there's a project at the end, And very, very similarly to 3200, it's just that 3200 had exams. 4300 did not have exams. This course will not have exams. There will be a big project at the end. And we're going to have some fun with this course. The second half of the course is going to be a lot of stuff to do with the project and with retail game AI and stuff. I think it'll be really fun. So that's cool that a bunch of people have done the courses with me before. And you'll find actually it's really interesting that as the course goes on, we'll get more and more random people joining the streams and asking questions in chat that have already been answered previously in the term and stuff like that. Okay. So my name, again, let's just go over this syllabus word for word so I can see if I made any mistakes. So again, this is the winter 2021 term. We escaped 2020. Thank God. Who else expected the clock at New Year's to go to December 32nd or something like that? It felt like 2020 would never end. But 2021 is gearing up to be a crazy year already. But anyway, we won't get into that stuff. So it's Computer Science 4303, AI for computer games. I'm David Churchill. I guess my office doesn't really matter because I'm not going to be there, so I hope you're not going to be there. But anyway, if you wanted to take the tour of campus, that is the Earth Science building on the 6th floor. My office hours, if you did any course with me last year, I pretty much have constant office hours. I live on Discord, right? So just ask me questions. I'll get back to you as soon as possible. If you need to schedule an actual meeting with me, just ping me on Discord or send me an email and I'll be happy to meet with you. So here's my phone. This is my office phone, so I probably won't be answering that. Just get me on Discord or email. Here's my email. My official email is dchurchill@mun.ca, but I don't like using that email because I didn't want to do that because I don't like the web client for the Mun email. So use my Gmail if you want quicker responses. Here is my website right here. You can click that link in the syllabus, and here is the course website, and I'll explain the difference between the course website and the D2L. So of course, this course uses D2L, the Desire to Learn, the Memorial University online learning system. But what I found with D2L, it's great for announcements and grades and marking and all that kind of stuff. It's awesome for that. But what it's not good for is rapidly uploading files and making corrections and stuff like that. So what we will have is the course website. So the course website, you won't need to access it often. So you're not going to be always having two browsers open. If you go to my website and then click on teaching, you'll see all the courses that I've taught over the years. And if you click on Computer Science 4303, you will have to enter a username and password to get access to this website, okay? That is available on D2L, but it will not be shared with the public, okay? That username and password is not to be shared with the public. If it is ever typed in Twitch, you are permanently banned from the chat, all right? This because it holds the assignments, and the number one thing that I don't want this year is the assignments getting out, because even though I'll get into this in a few minutes. Anyway, so in here, you can find assignments, you can find the lectures, you can find syllabus, you can find code snippets that I'm going to upload, all sorts of stuff like that. So for example, if you go to the assignments directory right now and you go to environment_setup.txt, this is actually instructions for how to set up the environment that we're going to be using for this course. Now, if you did 4300 with me, you already have this done. It is going to be the exact same C++ and SFML as 4300, except you're not going to really have to worry about SFML, okay? There will be some bonuses on some assignments that you may have to look at SFML, but if you are interested in how to use SFML and the graphics library, I can just point you to the lectures that I did for 4300. I don't need to take time out of this course to explain SFML. But we will have a lecture on C++ to get everyone caught up to speed, because I know there's a lot of 3200 people out there, or people who didn't take any course with me who may not be familiar with C++. We will be using C++ for this course, but not to the same extent as 4300. What we will be using for C++ in this course will be classes, some STL containers like vector, set, arrays, stuff like that, for loops, while loops. That's about it. Okay, so very, very basic stuff. The course is done in C++, but you don't need to be a C++ guru in order to understand it. Okay, so that's the course website and the D2L. Oh, I should go back. Here under lectures, there will be 2 folders in lectures. One will be slides. In the slides folder, I will post the PDFs for the lecture slides. In the videos folder will be the raw captures, the pure 1080p captures of this stream that you can download. Now, I would highly prefer if people watch the lectures on YouTube because of bandwidth issues. If we have 60 people downloading, a 500 meg or a gigabyte file, that might put a little bit of a strain on the university. And also, on YouTube, you can download it and you can just watch it at like 1.5 or 2x speed or something like that if you're trying to get caught up. So, and you can also watch it on any device. So YouTube is probably the best way to watch the slides. There will also be Twitch VODs. But what I'm going to do for the YouTube is when I do a lecture on Twitch, there's that 5-minute intro just to sort of let people get into the stream and get here on time. And then after the lecture, on Twitch, usually I go raid somebody to, find a small science streamer and give them some views, stuff like that, which is really nice. All of that stuff will be cut out of the YouTube lectures. So the VODs will be there on Twitch, but just realize that there's going to be some sort of behind-the-scenes stuff on Twitch and in the live lecture that you won't get in the YouTube lecture. But none of that has anything to do with the course. So don't worry about that. And then, of course, in the syllabus is the syllabus for the course, which I'm currently going over. Now, on D2L, I also... one other thing. So I just got a kind of sarcastic but also funny comment in the chat. Do subs get plus 5% per course grade? So let me talk about the Twitch... how I'm integrating the live streaming with this course. So officially, from the university's perspective and from my perspective, this course is being delivered via pre-recorded lectures. Okay? So that's officially how this course is being delivered. Pre-recorded lectures. But I'm recording the lectures on Twitch. Okay? So this is completely optional. It is completely optional to tune into Twitch. I've already gotten about half a dozen emails from people who have course conflicts or work scheduling issues, etc., or they're in, a different time zone and it might be too early or too late there. You absolutely are not being forced in any way to attend the live Twitch lectures. In a similar way, you are not forced to follow the stream, subscribe to the stream. I sincerely apologize that there are ads on the stream. I absolutely hate that, and I may actually switch to YouTube because of that. So I'm currently talking to Twitch support to say, hey, this is educational stream. I don't want any ads on my stream. Can you completely demonetize my channel? I'm asking them for that because I like the community feel of Twitch and the emotes and stuff like that, but I don't like the monetization side of things. And if there is a single cent made from any ad from any course, I will just, donate that to some gamer charity or something, okay? I am not financially profiting in any way from Twitch. From streaming these things, nor would I want to. So, or from my YouTube channel. None of those videos are monetized on YouTube at all. So, that is sort of, you are not forced to interact with the chat. You will not get any benefit from interacting with Twitch whatsoever. And all of the alerts for follows and all that kind of thing are completely turned off during the lecture. So that's just kind of the PSA or the FYI for how Twitch is actually integrated with this course. Okay. On D2L, I also gave out a link to this spreadsheet. This spreadsheet will be your life in this course. Okay. So this spreadsheet is where absolutely everything, it will contain all the links to everything you need to know for the course in terms of content. So the D2L is there for announcements and grades and assignment submission. The website has the files, and the files will be linked here as well. Okay? So here, for example, is a tentative course schedule. So if you open up the schedule, you can see every single lecture that we have during the class. So all the days, the lecture numbers, when the assignments will be given out. So far, the first half of the course, up until the winter breaks, this is pretty much set in stone. But the second half of the course is completely up for grabs. So what I try to do with my courses is I leave things a little bit flexible, and I want to see how things are going before I really set the lectures in stone, right? I want there to be flexibility, and I want us to be able to change things if people aren't quite getting it, or etc. So the first 3 assignments, these, like the start dates and the due dates, are already posted for that. And so our first assignment will be given out next Tuesday, a week from now. Also on this spreadsheet, you will see, like, eventually this is what this will look like. We will have PDF slide downloads, Twitch VODs, YouTube VODs, and download links. So if you did any other course with me last term, it will be the same. I've also got useful links here. So for example, I've got a link to my website, the course syllabus. If you're looking for a partner in the course, you can use this spreadsheet to sign up for a partner. I've got a link to all the, if we go here, for example. So this is the playlist for Computer Science 4300. This is all the lectures for there. So if you want to, say, for example, go into some more details about C++ or SFML or anything like that, you can come look at this course and see those lectures. Those are not required for this course whatsoever, completely voluntary. I will have a link to the playlist for this course once that playlist is actually active, but there's no videos up yet. Here's a link to the month calendar so you can see important dates, and here's that link to the setup instructions. So any other important links that I have will be posted to this spreadsheet. If there's some reason that you can't see this spreadsheet, please let me know. But you don't need this spreadsheet. It will all be on the website in terms of assignments, in terms of lectures, in terms of videos, etc. Okay. So I had a question here. Are partners mandatory? We will get to that already. So what is the objective for this course? Let's just read this out. This course is for students interested in learning about various techniques for artificial intelligence in computer games. Topics include an introduction to movement in games, search and planning, decision making, and procedural content generation. Implementation of course assignments will be done using the C++ programming language and the SFML graphics library. A final course project will be to implement an AI bot for a retail video game. So that's going to be pretty cool. So here's sort of the course outline. Here's what we'll be learning in the course. So we're going to first have a brief introduction to C++ and SFML. So we'll talk about syntax, semantics, a little bit of the standard template library, how to compile C++ programs, etc. And also an intro to game AI, which we'll cover today. And so that is like, what is game AI? Why does it matter? How is it different from academic AI, etc.? So this topic will have one assignment on it, and I won't spoil what the assignments are yet. Actually, let me spoil the first assignment. So for the first assignment, just to get you used to C++ and SFML and the structure of the assignments, we will be doing a Tron AI. So if you've never heard of the game Tron, go look that up. But it's like a snake that goes around and you try and block off people and stuff. And so there is going to be almost no instruction or goal for that. We're going to write a Tron AI, and then we're going to have an in-class competition for the Tron AI game. So that'll be really fun. So once you've all submitted your Tron AIs, we're going to have a live streamed competition for that. The second topic, the second overarching topic, will be movement in games. So a lot of AI in actual video games is not for like super complex AlphaGo like behavior. It's all about how do I get this thing from here to over there without looking like an idiot. Okay. And I see a bunch of questions about the project. We'll get to that. That's all going to be in the syllabus, okay? So, movement in games. First, we're going to talk about space representations, and that means how do we actually store how do we store the data for our level? How do we represent that? And I just noted that the course command in the Twitch chat is actually pointing to last year's courses, so I will be sure to fix that. So space representations, we'll be talking about grids, arbitrary graphs, triangulation, stuff like that. We'll talk about some planning and search. We'll talk about vector fields and influence maps, and this will actually be the topic of assignment 2. And then we'll talk about steering, smoothing movement, collision avoidance, etc. The next topic will be decision making. So we'll go over a bunch of different ways of performing decision making in games. So really, really simple things like finite state machines. Then we'll get into things like behavior trees, utility theory, and then we'll get into some more complex things like two-player search, minimax, alpha, beta, Monte Carlo tree search, stuff like that. Next, we have procedural content generation, or PCG. And PCG is all about dynamically creating content for games. Okay, so instead of a designer having to sit down and make all the levels for your game, for example, you could make levels for your game automatically with procedural content generation. So we'll talk about things like maze generation, map representation, map generation, so like rule-based, binary space partitioning, cellular automata. We'll talk about terrain generation, terrain smoothing, some fractal stuff, grammars for PCGs. We have lots of cool content about procedural content generation. And then at the end of the course, we're going to talk about game AI competitions and how to actually create a full AI for a game. So we'll sort of talk about an intro to these game AI competitions. We'll do some game AI bot case studies. So we'll do it for Prismata and for StarCraft. And then for a final project in the course, you're going to create a bot for either StarCraft or Prismata. Okay, and we'll talk about what those games are in the future. But as sort of homework that's not going to be graded, if you do want to get kind of a jump start on things, if you don't know what StarCraft Brood War is, and you don't know what Prismata is, well, you're going to have a choice between creating an AI for one of those two games for the final project. So go look up those games, and I will later in the course have an entire lecture devoted to those things and explaining it to you. But if you want sort of a head start, you can go look at those things. There is no required textbook for this course, so all I have done is link you some references that you might want, okay? So someone in the chat just linked to the Prismata Steam page, so thank you for that. It is a free-to-play game, so you can download that and play it for free if you want to learn the rules. And I will be providing a link to a download of StarCraft Brood War that you can play for free because the remastered version is out, so they don't really care about the old version. Someone asked, do we apply reinforcement learning in any assignment? No, there is no reinforcement learning in this course because reinforcement learning was covered in 3200, which is technically a prerequisite for this course. So we have already, at this point, you should have already done reinforcement learning. Okay, so here's the part you want to know about, which is the evaluation of the course, okay? So this course is going to be 50% assignments and 50% projects. So we're going to have 4 main assignments. Well, there's going to be 5 assignments, okay? So technically the project setup milestone, I'm considering that an assignment. So our first assignment we will have on Intro to C++, then we'll have Movement in Games, then we'll actually have PCG, then we'll have Decision Making. So there'll be assignment on each of those. Next, we will have an assignment where you're going to have a... Let me restart. Then for the project, you're going to have to submit a project proposal to me saying whether, like, what type of project you want to do and the scope of that project. Then we will have a project setup milestone. And what that is you are going to submit to me proof that you have set up the API for that game and you have taken the example bots that are available for that game and you've compiled them and you've run them. Okay? Because as most of you know, and as I know because I was a student at this very university, the hardest part about a project is starting it, right? Because if I give you 2 months to do a project, or if I give you 2 weeks to do a project, you're going to start it with 1 week left. Doesn't matter, right? And so what I want you to do there's going to be this is going to be a month and a half before the project is due, is you're going to have to set up the environment for the project and prove to me 4 marks that you have done that early, okay? Then you're going to, at the end of the course, at some point before exams are over, you are going to give me the full project code, and you are going to record a video presentation for your project, which will be between 10 and 15 minutes long. But I'll give you details about all that later. So someone asked about group work. So assignments and the project are going to be done in groups, okay? And it says here, less than or equal to 2 people per group for the assignments. And so that means, so the assignments that I have created with a 2-person group in mind, okay? So yes, you can do them alone. If you really want to work alone and you're a keener and you think you can get it done, fine. I have nothing against that. But they are designed to be enough work for 2 people. Please keep that in mind, okay? And if I find out that 2 people are submitting their own single assignments, but they work together, that's cheating, right? So just form a group. It's just less work. There's no reason not to form a group. Now, before in my courses, when I had a project, it was up to 4 people per group for the final project. So for example, in 4300, we had groups of 4 for the final project. I think 2/3 of the course, 2/3 of the groups either had someone drop out, someone just completely stop responding to people, someone not pulling their weight, someone getting sick, someone having, it's just crazy how many people got hard carried through those projects, okay? And how many frustrated group members there were. So what we're going to try for this course is that the project difficulty will go down a little bit, so it's no longer 4 people worth of work. It will be 2 people worth of work, but it will be a solid month of work for 2 people, okay? So it's a 2-person project. Do not do the project solo, okay? Unless you are really masochistic, okay? Do not do the project solo. Please find a partner for the project. If there are an odd number of people in the course, I will possibly allow groups of 3, but those groups of 3 will have to do extra work, okay? Now here comes the scary part. This is always the scary part, but let me read this. Due to the online group nature of this course, to show that you have individually learned the material, you must pass the final project to pass the course. If your grade on the final, sorry, this is supposed to be project. I'll fix that. If your grade on the final project is less than 50%, then your overall course grade will be equal to the mark that you received on the project. If your project grade is greater than or equal to 50%, then your course grade is determined by the scheme above. And so what that means is that this course is entirely online. We are going to have people cheating because there's dirty cheaters everywhere, okay? Caught them last year, and I'm about to give a big tirade about cheating, so stay tuned for that. And it's all online, and because it's all online, there's going to be cheating. And also, the project is the main point of this course. So I don't want someone to get a 50 by acing all the assignments and then not even start the project. Okay? Because that's not the point of this course. So, rather than make the project worth 80% of the course, we'll make the assignments worth a bunch, but you just have to pass it. Okay? And trust me, so in 4300, there were 3 groups that didn't pass the final project, okay? They each got around a 30 to 35% because almost nothing got done. They just didn't get it done. But instead of just saying you fail, okay, I gave those people extra work to do, or they could work on their project over the Christmas break and submit it to me to get that 50, okay? So this does not mean that if you get a 49, you instantly fail the course. It means that if your project was basically not done in any sort of way whatsoever, you're going to get a second chance, and then if you fail the second chance, then you fail the course. okay? So please try on the project. It's the whole heart and soul of this course is to get the project done. So then there's some, red tape that I have to cover, but you can read. You know all about the MUN policies at this point. You should be a fourth-year student in the university. Okay. So someone in the chat said, "Oh God, this is giving me college anxiety all over again." No, don't. It's not going to be anxiety. This should not be anxiety. This rule is not there to punish you. It's just to say that the project has to be at least half-assed, okay? If not 2/3 or 3/4-assed. If you full-ass the project, then you will get a great mark in the course. All right. Now, about cheating. And I have to say this. I can't believe I still have to say this. Don't cheat. It won't be worth it for you. If you did 3,200 with me, you know that I'm serious about this, and you know that I will sniff it out, okay? I had one person in 3,200 who cheated on the midterm, cheated on an assignment, and cheated on the final. And every single time, "Oh my God, sir, please give me a second chance, I'll never do it again." Second time, "Oh my God, sir, please give me one more chance, I'll never do it." Like, don't cheat. If it is going to be far more beneficial to you to just not do an assignment than to cheat on an assignment. Trust me, okay? Because in this course, if there is proof that you have taken things from online without... Now, you are allowed to use sources online, but you have to cite them, okay? You will not just be able to Google these assignments. It's not like, implement a vector where there's 1,000 of them. These are completely custom assignments that I have made that you will have to fill out that you probably can't Google, okay? But if you cheat with other groups, or like we run all of these assignments through the MOS anti-cheating system, we have our own custom anti-cheating system, I know what I've taught you, I know what you're capable of, I've been doing this for a lot longer than you, we will smell it if you're cheating, okay? And if you're cheating, you just get a 0 in the course. So you may as well drop it, okay? I know that there's COVID. I know that you're home. I know that some people are not feeling the best this term. But I am going to be less strict with the marking, but more strict with the cheating. Okay? So literally all you have to do is try and don't cheat. Right? Because cheating isn't an accident. You have to go out, you have to search for stuff, you have to plagiarize it, you have to put it in your own code and test it and see if it works. So just don't do that. The 10% that your assignment is worth is not worth failing the course. Okay? So just again, I will be telling the TAs that we are going to be, not as strict with the marking of things, but we will be very strict with the cheating side of things. Now, you do not have to worry about 2 or 3 of your lines of code showing up on Stack Overflow somewhere, or if you say Google, how do I do file reading in C++, and you copy that little paragraph of opening a file and reading it. No, that's not what we're talking about. I'm talking about taking someone else's assignment that was accidentally posted to a public GitHub repo and just submitting it, okay? We had that happen in 4300. So here's another thing. If you are allowed to use GitHub to collaborate with people or similar online repositories, but those repositories have to be private, okay? GitHub is a searchable repo. You can type in COMP4300, and I found 6 or 7 active assignments and had to get after those people to take them down or make the repo private. So if you want to test if your repo is private, take the URL of your repo, post it into Microsoft Edge, where I know you're not logged in. I hope you're not logged into Microsoft Edge. And then you'll see whether or not it's available, right? Test to see if your repos are private, because posting your assignments publicly is cheating. So here is what's cheating in the course, okay? Copying off of other groups' work is cheating. Posting the assignments publicly is cheating. I'm just not even your solutions, but just the assignments, okay? These are copyrighted assignments that are not to be posted online. That is cheating. Coming up with Googling entire solutions to an assignment, which you shouldn't be able to do, but if you do take stuff offline, if you say, hey, I found this really cool random number generator for the PCG assignment, here's where I found it. Link that Stack Overflow post or link that website. That's fine. But if you just take something from online and you paste it and you do not give it credit, that is plagiarism and that is cheating, okay? And I know that you're saying, oh my God, Dave, move on from this. I had at least a dozen people cheat in both courses last term. 2 people got zeros in both courses. A bunch of people got second chances because it was minor cheating. But man, it's crazy. Just your 4th year students, don't be cheating, okay? I've warned you. I'm going to be very strict about it. And I actually wanted to have a hall of shame where I could publicly post people's names who were cheating, but that was frowned on by the university. But I won't do that, but please, please, please do not cheat. There is no excuse for it. None. I don't care what happened in your life. Come to me, okay? So if you are sick, if you have a family issue that is preventing you from getting your assignment done on time, I'd say there were at least 30 to 40 cases last term where someone said, hey, my family's going through a tough time. I'm sick. Here's my doctor's note, whatever. I just gave them an extra few days, okay? It's fine. If you legitimately need time, send me an email. I'll get you extra time. If you need more help, ask anyone who has done any course with me how much time I spend on Discord, answering questions, in private messages, reading your code. I will put a lot of effort into this course to try and get you through it. But 2 rules. No cheating. And don't come to me with 2 days left in the course saying, hey, I want marks for assignment 2. Okay? So one thing that has happened to me a lot is that people wait until the last week of the course to come up with, hey, for all 4 assignments, my partner didn't do anything. Well, why didn't you tell me that after assignment 2, right? Don't come to me in the last week of the course. I will have infinite sympathy for you if you come to me when a problem is happening. But if you wait weeks and weeks, if not months, to tell me about problems, then not only will I have less sympathy, but there is less that we can actually do about it, okay? For example, if you're doing a project in a group of 2 and your person hasn't done anything for 2 weeks, why not come to me after a few days, right? If your person isn't responding after 3 or 4 days, come to me. I'll send them an email. We'll work it all out. I've done some healing in the past, etc. So that's it. That's what I'm going to say about that. When cheating happens, I'll let you know about it, because even though I have said this, I will bet any amount of money that it will still happen. So I gotta say something like this. If you cheat in school, you will cheat at your job. You will cheat on your spouse. Be the person. Be in this course the person that you want to be for the rest of your life. Okay. If you take shortcuts here, you will take shortcuts at your job. You will get found out. You will get fired. All right. Learn the material. Cheat by actually studying it. Put all the answers in your head. That's the best form of cheating. All right. So someone in the chat is asking about how to find a partner. Here is a spreadsheet. It's called Looking for Partner. I will open it up. On that spreadsheet, you can put your name, you can put your email, and someone can contact you and say, hey, I want to be your partner. You can contact someone else. As soon as you find a partner, please remove your name from that spreadsheet. That is a publicly editable document, and the link is here on this spreadsheet. So please use that. Or you can post in Discord saying, hey, I'm looking for a partner, okay? Alrighty. So what else have I not covered? I think I've covered the syllabus completely. Okay, so that's the syllabus for the course. And now that I've wasted half of the lecture, let's actually get into the lecture part of it, okay? The Google Doc was linked in the Discord post. So everything should be in the Discord post. Oh, and by the way, my website, so if you go to my website, right now, if you click this is just a directory listing. I'm going to be making a legitimate website for the course, which will have links like that kind of look like this rather than what it is right now. So that will be updated. I just haven't had time to do that yet. Alrighty. Okay. So let's get into the PowerPoint and the content for this actual lecture. Boom. All right. So Computer Science 4303, Lecture 1. We just did the syllabus, and now we're going to get into some actual content. So what we're going to be talking about here is what is the difference between academic AI and game industry AI. If you did 3200, you know a lot of this already, but there is definitely a difference, and I want to explain what that is. So what is academic artificial intelligence? So what is artificial intelligence? So what is intelligence? Oh my God, we could have like a PhD thesis on this, but let's just give a quick overview. So intelligence is some capacity for learning, reasoning, understanding, or problem solving. Basically, does it look intelligent, right? Does it do something that requires any sort of decision making? So artificial intelligence is then building a program or a machine that appears intelligent to the user in some domain. And in academic artificial intelligence, what they're striving for is to build some sort of strong or general AI system that's sort of an AI system that's just good at everything, right? That's the holy grail of modern AI, is like, that's Google's big dream, right? Is to build an AI that's good at everything. So this is John McCarthy. John McCarthy coined the term AI. He's a pioneering computer scientist. He developed Lisp, he won a Turing Award, and he said that AI is the science and engineering of making intelligent machines, especially intelligent computer programs. It is related to the similar task of using computers to understand human intelligence. But AI does not have to confine itself to methods that are biologically observable. So that last thing is really important, because some people, if you say like, what is AI, they'll think of like robotics, like making something act human. Or someone might say that, you know, the algorithms have to be biologically inspired to be AI. It's not at all. Like, if statements could be AI if you really want to. Okay. So academic AI, what is sort of the process or the goal of academic AI? Well, in my opinion, this is what it is. Let me get my laser pointer out here. So academic AI typically wants to create the most intelligent system for a set of tasks using any available resource, okay? So you're creating this system, and the goal of that system is that you want to publish papers that are about some research that you've performed, okay? So academia is all about publishing papers saying, hey, look what I did that's really cool. So you're interested mostly in theoretical performance, but lately academic AI has also gotten into more practical performance metrics. You're interested in things, if possible, that can actually be proven. Okay, so proven meaning like mathematically show that this thing is better than this other thing. Typically, AI is interested in non-game related problems, but more and more recently, AI has been using a lot of game related problems. And here's something that's really important, is that academic AI traditionally has very few end users for their work. Okay, so if you're doing, say, your master's thesis, it's very likely that you are the only person who's ever going to see that code or ever going to run those experiments. And so that is an important point, because academic AI is really interested in the theoretical side of things, and then the coding side of things, the practical side of things is like, get it good enough to run an experiment and then forget about it, right? It's in some zip file in a folder on an external hard drive that no one cares about. That's almost the opposite of game AI, so retail game AI, and we'll talk about that. So how is academic AI research performed? Well, here is sort of the walkthrough of my life, right, in terms of academic AI research. First, you identify a problem or an area that you want to work in. So you could say, for example, I really like neural networks, so I'm going to try and improve neural networks somehow. Or you could pick a domain, like I really like StarCraft. I'm going to try and to do something new for StarCraft. Or I really like, well, I don't really like, but I really want to help people with cancer, right? So you're going to identify either an area to work in or a problem to work in. Then, before you just go start programming, you're going to do a literature review of existing techniques. Because if you haven't done a literature review, so you haven't gone out and read all the papers and the theses and stuff about a particular topic, chances are that if you have an idea, it's been done before. And so in academia, you can't publish a paper that's already been published, right? You can't publish an idea that someone else has already done, because who's to say you didn't steal that idea? So you need to go out there and you need to review everything that's been done before you start working. So then you develop new techniques, right? This is like the Gary Larson comic where it's like a miracle occurs right here. Somehow you develop something new. This is the hardest part of academia to me, is coming up with new things. Once you have a new thing, then you're going to test that new thing against the current state of the art under specific controlled circumstances. You're going to analyze the results of those experiments, and then if your results are better than the previous results, then you can publish a paper. That's basically how academic AI works, right? And not only AI, but this is how most of academic research occurs. So AI is no different than anything else. It's think of something that you care about, do some research in it. If the research is better, you publish. So here's some examples. A master's student doing academic research will spend 2 to 3 years doing coursework and AI research, right? So the first year is probably going to be courses, and then the next year or two will be doing their research, writing their thesis, performing experiments. A PhD student will do the same thing, except probably spend 3 to 7 years working on a subfield of AI, typically around 4 to 5 years though. To produce, say, a new algorithm or a new method or develop something new. So a PhD student is doing, hopefully, something that's significantly more impactful than an MSc student. If you are Google, you're going to spend $100 million on deep learning to play Go or StarCraft, right? So there's all sorts of different AI research that's going on, and it's in the last decade we've seen a real trend toward industry doing more academic AI research and then spending so much money that it's completely unfathomable. So when we talk about AI, we actually want to categorize it somehow, right? We just don't want to just say, okay, AI, well, what is AI, right? So when we categorize AI, we're doing one of two things. We're either categorizing the algorithmic techniques that we're using, or we are categorizing the application domains that those techniques get applied to, okay? So here's an example of a categorization of some of the subfields of artificial intelligence. So for example, AI can be, now this is not all of them. This is not an exhaustive list. It's just some of the more popular ones. So for example, machine learning is a subfield of artificial intelligence. Some people, especially recently, might tell you that AI or machine learning is all there is to AI, but that's not true at all. So inside machine learning, we have things like prediction, we have deep learning, etc. We could have natural language processing. So this would be things like Google Translate, translation, classification, information extraction. We could have speech, that's part of AI, expert systems, planning, scheduling, and optimization, robotics, vision. So these are some of the application domains for artificial intelligence. this is sort of where my research is, okay? So I do some research into robotics. Most of my research is planning, scheduling, and optimization, or heuristic search falls under that, for video games, and I do a little bit of machine learning and reinforcement learning as well. So what is the current state of the art when it comes to artificial intelligence then? Where have the biggest breakthroughs been made? Well, in my opinion, more recently in machine learning and in heuristic search, okay? So especially in machine learning, with deep learning in the past 10 years has become incredibly popular, but also heuristic search, not only because it's my field of research, but also because it has contributed a lot in more recent things. So machine learning, we're not going to break down machine learning, but just to let you know, there are 3 types of machine learning at a high level. There's supervised learning, unsupervised learning, and reinforcement learning. Of course, you know what these are because you did 3200. And then we have search-based AI, or heuristic search, which is more of sort of like an exhaustive process of searching all the possibilities that you can do in an action space. And we did that in 3200 as well. And for those of you who are wondering why I keep saying 3200, 3200 is the Intro to AI course that is a prerequisite for this course. But in the past few years, search and machine learning have been combined to form systems that are just insanely powerful. So researchers combine the exploration of heuristic search with the learning of policies and state evaluations to produce way better results than you can do with just search or just learning. So this is what AlphaGo did, right? It used a combination of heuristic search with Monte Carlo tree search and deep learning in order to create like a really powerful system. I gave these slides in 3200, so I'm going to go really fast through them now. But what could AI actually do for us? We could do things like Google Maps. Google Maps is a heuristic search algorithm, right? So planning and scheduling, we can have autonomous control for things like robotics or self-driving cars. We can do image and pattern recognition, facial recognition being one of the more evil things that has ever been invented. I am completely against the use of facial recognition for everything. We could have healthcare systems, so like robotic surgery, brain tumor recognition, all that sort of things. We have robotics, so we could have swarm robotics or intelligent robotics like Boston Dynamics over here trying to create Skynet, etc. We can have musical composition, we can have art, we can have procedural content generation, we can have language processing and translation, we can take over the world, obviously, right? But this course is concerned with game playing, right? How do we play computer games, especially, or video games with game AI? Okay, I know I just flipped through that really quick, but 3200 is the prereq, and we already covered that stuff in 3200. So how do we test new AI? We play games. And the cool thing, and the reason for that is that games measure intelligence, right? And so in my opinion, everything is a game. Everything. Everything in life is a game. It could be a funny game, a serious game, a sad game, but it's a game, right? Your goal, ideally, is to get as many points as possible. Those points might be money. It might be long life. It might be running the 100-meter dash as fast as possible. Like, you have some heuristic evaluation that you are trying to maximize in your life. Most people call that happiness, but maybe some people aren't trying to maximize happiness, you know? Some people have 5 or 6 kids that they're trying to take care of, and maybe it's not fun to do that, but you have to, right? So, in my opinion, everything in life is a game, not only things that we call games. And so AI for games is a very important topic. So what is a game? You have an agent in an environment. That agent can take actions, right? Maybe we have a chessboard, we have a Space Invader, we have a Mario, whatever. And the actions affect that environment. So the agent has a goal. We want to defeat the opponent. Mario might want to move to the right. Sudoku, maybe we want to solve the puzzle. Donkey Kong, maybe we want to get the most points, right? But all we want to do in a game is maximize a function. And that, in my opinion, is what life is about as well. It's just that coming up with that function is very difficult. And maybe it's not just an integer, it's some Pareto optimization or something that can't be quantified. Okay. Games are also important, especially video games, because they can simulate the real world. And so if we can have an AI that has success in a video game, that success could translate maybe to a real world problem. Also, there's no ethics required for computer games, right? You can make a GTA 5 bot that, runs over all the people that you want. You don't have to apply for ethics for that. It's very difficult to get funding to do a similar project in the real world. It's very cheap. You could go buy a game for like $10 versus a robot that might cost you $10,000 or $100,000. It's very easy to visualize, and it's intuitive to show your results for games, right? So for example, if you create a Mario or a Doom playing AI, people could see that and say, oh wow, that's actually pretty good at the game. Versus maybe something like protein folding, which someone tells you is really important, but is it intuitive why that's important? I don't know. It's really fun, in my opinion, to program AI in games, and because it's fun, it helps people to learn, right? We also have this sort of man versus machine or human versus machine thing going on in AI, where we try and beat the world's best humans at things. So, for example, here we have chess, we have poker, we have Jeopardy, and we have Go, and in all of these cases now, computers or AI systems are better than humans at those respective topics or those respective games. Although I think it was a little bit, if you saw the type of one in chat, if you saw IBM's Watson beat up the people for Jeopardy, because I thought that was a little bit of bullshit because the AI could press the buzzer instantaneously, right? So that wasn't really cool. All right. So I already said this. I don't need to say it again. I just talked about human versus machine. I already said that. Okay, so industry video game AI. Here's what industry game AI is. So when I say artificial intelligence, we're talking about academic artificial intelligence. When I talk about game AI, we're talking about industry video game AI. Here's what video game industry AI is. The game designer needs an AI feature in the game. Like, this character has to be able to walk over here without hitting anything. And you have to implement it. That's game AI. That is industry game AI. Done. Okay? Your boss tells you they need something, and you implement it. That's what it is. The designer needs a feature, you implement it. It has to run very, very fast. You can't have something like Deep Blue that might take minutes to decide on a move for chess. You might have 1 or 2 milliseconds, if you're lucky, for your AI system to run in a retail video game. 1 or 2 milliseconds. Have fun with that. Oftentimes, you have less time to implement a feature. So a master student or DeepMind might have 3 or 4 years to make their AlphaGo system. You might have 6 months or 6 weeks to implement a new feature for a video game AI. So you're not necessarily trying to be the most general, powerful AI in the world. You are trying to get that designer's feature implemented under time, under budget, and run as fast as possible. And so it's not like academic AI in that sense. It's very less generalized and it's more hard-coded, right? So your solution to your problem in your game may not be applicable to the real world. It may not be applicable to other games. It might be a little bit hard-coded, right? To say, okay, this is going to solve unit positioning in StarCraft, but nothing else. And that's fine, because you're solving the problem that your job had you do. And, very importantly, the resulting AI has to be very stable, because it might be used by millions of people, right? So whereas academic AI, you might write a one-off experiment that you just generate some results for a paper and then throw it away. That happens way too often. It's brutal because you can't do results verification and stuff. But your game AI has to be extremely stable. And so software engineering comes more into effect in game AI than it does in academic artificial intelligence, in my opinion. So, but this doesn't mean that industry AI or game AI is worse AI. It means that it has a different goal, right? So it's a tool to solve a different problem. So the goal of the AI, well, I guess the overarching goal is to make the company the most money, right? But in alignment with that goal is to entertain the player and make them happiest, not to be the most intelligent. Because if you have a system like AlphaGo for, let's say, Call of Duty, where the bots just shoot you between the eyes every time you appear on screen, that is not fun. No one will want to play that game. They want bots that have different difficulties, that do different strategies. Maybe they miss some of the time, maybe they hit some of the time, right? That is entertainment value, not most intelligent. Actually, you could argue that it's more intelligent. It's a more difficult problem to be fun than it is to be intelligent. And yeah, so fun is often a much harder goal because it's not a numerical value that we can test for. And so industry AI programmers, they often have a much deeper knowledge of implementation than academic AI programmers do, due to their constraints on the game. And so with industry game AI, the AI should be exactly smart enough, but not smarter than necessary. And the reason for that is because as an employee of a company, your time is money, right? So if you are implementing a bunch of features that aren't necessary and making the bot smarter than it has to be, that's wasted time, right? And it's wasted money for the company. And so it really is a very practical purpose in industry game AI is you have to implement this thing on time, under budget, and be exactly as smart as we want it and no more. And so not only that, but with game AI, you're not necessarily doing experiments to numerically judge the intelligence, okay? The intelligence required, it depends on the interaction between the agent and the players. And the longer the AI interaction is on the screen, the more likely it is to look dumb. And so I wrote the AI for Prismata. And Prismata is a strategy game that we will learn about in the course. But it was a really humbling and fun and challenging experience to write an AI for a video game. Because what happened was the following. My AI did a bunch of really intelligent stuff. But guess what all the Reddit posts were for? The mistakes, right? It was like when the AI did something that a human would never do. And that's very difficult to try and fix those mistakes. So oftentimes, your goal with the AI is to accomplish a designer-specific task and not make really big mistakes that humans would notice. And that can be a really challenging process. And it's very easy to misinterpret the intelligence of things, and that can be both for good and for bad, right? I remember reading things on the Prismata subreddit about what they thought the AI was doing behind the scenes. So, for example, in Prismata, there are different colors of resources, kind of like in Magic the Gathering. And like red is aggressive, green is technology, blue is defensive. And it would say, oh, the AI is like super aggressive. It's scared of going technology. It really likes going aggressive. And that wasn't it at all. It just happened to be how the search system thought that the AI, like, it was evaluating that better than something else. And so it was really interesting to see how people thought the AI worked versus how the AI actually worked. And in some cases, it made me really happy because they thought it was super complex when it really wasn't. And in other places, it was really disappointing because something I thought was really well done, they just took as really dumb. So you've got to be able to take it on the chin a little bit when you're releasing a video game. And it's not just about intelligence. So game AI often involves aspects of games that aren't strictly intelligent. So we will not be covering these topics in the course, but these are very important when it comes to game AI. So good AI is good animation, right? Your path that you find could be as like the shortest path possible. It could be really intelligent. But if your character is just like sliding along and not animating smoothly and not having the right transitions, it looks dumb. And so all your intelligence of your AI is stupid. Like, who's seen like the T-pose from, we won't get into a lot about Cyberpunk, but like, you could have a lot of really smart systems under the hood, but if you have bad animations, there goes your game. It's good game design, right? Because you want to design a game where AI is necessary. Like, for example, World of Warcraft. You don't want good AI in World of Warcraft. You want scripted sequences of events that the hardcore nerds are going to grind over and over and over again in order to beat the mythic boss and, scream about on Twitch. You don't want the NPCs of the dungeon like blocking you off and protecting their healer and stuff like that, because the game would be too hard. So you kind of want some AI to be dumb. And the game design, how the game is designed, has a big factor to play in how smart you want your AI to be. It's good sound design. If your sound is off or weird, the AI looks dumb. And it also studies human behavior. If you have human characters that you're trying to apply AI to, then you've got to study humans and see what they would do in a situation first. But we're not going to go into that in this course. So how do we build good AI? Well, we observe the world, right? If you've got some open world like Grand Theft Auto or Cyberpunk that you want to build good AI for, or Skyrim, okay, maybe Skyrim, its AI systems are kind of fun sometimes to analyze. But you look at what humans would do and try and mimic that in some sort of way. How do people move in conversations, right? Like, for example, one of the big memes now about Cyberpunk is how if you like punch an NPC, all the NPCs around it will just cower in fear for like 10 minutes, right? That's not good AI. That's not what people would do. How far apart people stand. Are people talking to each other, like right next to each other, or do they spread apart? How a new person joins the conversation, how people avoid each other in the street, how gaze is adjusted, right? Like, are they looking at the character when they're talking to them? All these things are super important, but again, that's like completely dependent on your game implementation and your game design. And so we're going to be covering more general things in this course. And one interesting thing is that game AI is kind of like theater. Okay, so I'm talking about like Shakespearean theater, like to be or not to be, like grand gestures and stuff like that. Exaggeration is often key to game AI. People won't notice the AI if they can't see it. Here's a story from Halo. I can't remember the name, I apologize, but this is from the game AI programmer of the Halo series. So he said, in Halo, the grunts run away when an elite is killed. Initially, nobody noticed that. So in the game of Halo, there's a bunch of grunts, and then there's elite with that pack of grunts. The elite is kind of like the leader of that pack. And they wanted the grunts to run away if the elite is killed. So in the first thing, they said, initially, nobody noticed that. So we had to keep adding clues to make it more obvious. By the time we shipped, we had made it so not only does every single grunt run away every single time an elite is killed, but they all have an outrageously exaggerated panic run where they wave their hands above their heads, they scream in terror, and half of the time one of them will say, "Leader dead, run away." I would still estimate that less than a third of our users made the connection, right? So here you have a game designer that came to the AI team and said, listen, there's a pack of NPCs here. When the leader is killed, I want the followers to run away. I want that to be a game design choice so that the user will say, oh, I only need to take out the leader. I don't need to kill all the grunts. But it's hard to convey a behavior to the user, right? So this is, I saw a good quote by actually Matthew McConaughey of all people, who said that, like, I have an idea, there's a truth, and then there's my representation of the truth, there's the words that I form, And then there's how you interpret those words. And there's a distance between all of those things, right? And so, like, the goal of the game is to have grunts run away when elite is killed. And then there's the game designer's belief of how that should work. And then there's the implementation of that belief. And then there's the user's interpretation of that implementation. And there's a distance between all of those things. So it's almost like a game of telephone, if you ever played telephone, right? It's where going from your game design decision to the user's interpretation of that it's very difficult to bring those closer together. And so that's one of the key things to game AI. So you want to communicate the AI effectively somehow to the player to let them know that this is what's actually happening. So you use audio, you use video, you use anything that you can. You use a rumble pack, doesn't matter, right? And you only simulate and build what you can effectively communicate. Do not build entire systems that the player will not see. Okay, if you like do some play testing and you find that the users run through the level in a certain way 99% of the time, then don't put all the cool details in places that they won't see. Entertain and engage the player with the AI. The goal should not be to slaughter them, right? Nobody just wants to spawn in and die. Okay, you want to have an entertaining fight. You want to have a close fight, ideally, with the AI system. So some AI design goals. The AI should ideally provide some sort of new player tutorial. Maybe your game has a steep learning curve and the AI can help you do that. Experienced players want more of a challenge, right? And so you may want a really difficult setting for experienced players to keep them interested in the single player experience. So if you have a good AI system, then you can... you have better replay value, and so your game might sell more copies. You could have some things like, let's talk about the implementation. Maybe we have a modular design, and I'll get into this when I talk about the design for Prismata. But in Prismata, we wanted different AI difficulty settings, and we wanted things like, so in modern video games, your game might be patched, right? So let's say we have a StarCraft AI system that has this really cool build order to get to Hydralisks as fast as possible. What if we patch the game and now the cost of a Hydralisk changes, right? So our AI can't be super hard-coded. It needs to have some modularity and some flexibility to it. And if we have that, then we have better in-game AI, more intelligent NPCs. We could also create offline tools. So we could do things like maybe we could even do game balancing, and I'll get to this stuff later. And we sell more games, right? Because video games are an absolutely huge market, hundreds of billions of dollars. Video games are bigger than music and film combined, and they have been for a decade. So tangible stuff here. All right. I want to talk a little bit about the research that I've done, just some of the topics, so you get a feel for what I'm into, so you can ask me questions. And going forward with the StarCraft and Prismata stuff, this is going to be more interesting. Technically, the time is up for this lecture, but I went a little long with the syllabus, but that's great. If you want to tune out, you can watch the VOD. So one of the first things that I did in my research is build order optimization and planning for StarCraft. So what is a build order in StarCraft? So let's say we want to build some sort of army in StarCraft. Like I want 10 Marines and 3 tanks, right? So in order to get to that, I'm going to need to perform some sequence of actions. So a build order is a list of buildings or units to build in a specific order. It's a build order. And so for example here, I've built 3 workers, a barracks, and then that barracks can train some Marines, right? So a build order planning system is a system in which we can feed in a goal, we can feed in a current state. So let me move my, I won't move my camera. And then what I did was build an algorithm in here. It was a search algorithm similar to the search algorithms that we looked at in 3200 that produced a build order sequence that said build this unit, then this unit, then this unit, then this unit. And so what you got in the end was this cool tree search algorithm Okay, it was called a depth-first branch and bound build order search algorithm. And so what it did was it produced multiple build orders, and the longer you went with the search, the better the build orders got. So you didn't, unlike something like A star that will only show you the best solution when it's done, this algorithm, if you run it for a little bit of time, it will give you a solution, but if you keep running it, it will give you better and better solutions. So for example here, the first build order, this is the example of trying to do a build order search for 2 Dragoons as Protoss in StarCraft. So if you build like probe, pylon, gateway, cybernetics core, assimilator, Dragoon, probe, pylon, Dragoon. That was the first build order that the search got. It found you can get to 2 Dragoons in 5,400 frames. And it runs at 24 frames per second. So how long is that? That was the first solution. As you go from left to right in this tree, you can see that the solutions, the different build orders, get better and better as you go. Let's say that I wanted to time out. I can time out at any time and it gives me a particular build order, but if I let it run to the completion, then I will get the best possible build order in terms of time to get to 2 Dragoons. That was one of the first things that I did. Next, I started looking at combat in StarCraft. So I developed a few search algorithms. I wrote a combat simulator for StarCraft called Sparcraft. Aren't I clever? And so it has its own client. It's available online. And so this was all about things like, remember how we did alpha beta search for Connect 4? Well, this is essentially a modification of the alpha beta algorithm to allow for actions that have durations and stuff. And so this is actually alpha beta, you can see it up here, running in StarCraft to do unit micromanagement. And so it was another, again, a tree search algorithm. But in this tree search, one of the really interesting things was that actions had durations. So for example, if you have a Zergling against a Marine, a Zergling might get to attack 2 or 3 times before a Marine can attack. And so the alpha beta algorithm had to be modified to incorporate that. I also organize and run the StarCraft AI competitions. And so the StarCraft AI competitions are actually run at Memorial. 1 second here. So the AI IDE competition is the longest running competition. This is an old slide. This is supposed to be 2020. I don't know why that wasn't changed. So I organized that along with Rick Kelly. It's held at Memorial University. There are 2 other major StarCraft AI competitions that have been run since 2011. We have, someone said that's too clean to be an AI lab. This is actually a computer science lab from the University of Alberta. And a really a nice photo that I took of StarCraft running on all the computers there in the lab. It's an international competition, and we've had lots of competitors from all over the world, multiple years, so it's a really cool competition. So I organized that. I also wrote a bot called UAlberta bot, and we will be studying this bot in detail in the second half of this course. So this class is going to be pretty fun, I think, towards the end. We're going to talk about like how a real AI for StarCraft can work. This bot has been competing since 2010, so it's 10 years old now. Wow, I can't believe that. It plays any of the 3 StarCraft races. It has a bunch of different strategies. It's kind of better at rushing strategies than late game strategies. And so what I did is when I designed the bot, it has this really nice hierarchical structure that we'll get into in fine detail later in the course. But what I did was I made it a modular system that was initially all hand-coded rule-based system. So if this, then this. If this, then this. And then what I did is over time, I started replacing the hand-coded systems with the dynamic search-based systems that I had been writing as part of my research. Right? So for example, the hard-coded build orders got replaced by the build order search system. The hard-coded when should I attack got replaced by the Sparcraft system, etc. So we'll talk about how that works and how this could be potentially part of your project later. So UAlberta bot did really, really well in the first 5 years. I stopped working on the bot in 2015. And so, it's done progressively worse over the years because of that. But it actually did win the competition one year, so that was pretty cool. And it was the first bot to play the random race. So it can play all three races equally well. The last another thing that I did was the AI for a game called Prismata, and this AI was called Hierarchical Portfolio Search, and we will get into this in detail later as well, because this is also something that you can do for your project. So just to let you know, the StarCraft AI is only available on Windows. Because StarCraft only runs on Windows, you can kind of hack it and run it in Linux. If you're able to do that, more power to you. I will let you do that. But I'm not going to support that officially. The Prismata AI will run on Windows, Mac, or Linux. So if you're on Mac or Linux, you're pretty much going to be using the Prismata AI. I may introduce another project later, but we'll see how that goes. So Prismata is a strategy game. Think of like a mix between StarCraft and Hearthstone. Okay, so it's available for free on Steam. Just look up Prismata Steam and it's the first link. It's completely free to play, and I mean actually free to play, not like pay to win. And so this will be one of the possible projects. It's got a huge state space. Units have different properties, and so it's not possible to just apply search naively to this game. So we'll talk about something called hierarchical portfolio search, where instead of searching over every possible move combination, I actually generate a subset of moves and look over those. So we'll talk about how HPS works and how you can write an AI for Prismata. I've also started doing some work for AI for video game development and design. So for example, when I worked on Prismata, I wrote this puzzle solver, which was really cool. So in Prismata, some of the extra content that you can buy are these sort of like puzzle packs, where think of like a chess puzzle where you have to find checkmate in so many moves. It's like that, but it's like Prismata. So what I did was made this nice user interface where you could easily add units or subtract units, and then the designers of the puzzle could click solve, and then the search algorithm would solve the puzzles. And so you wouldn't have to like make one little change, add a unit, and then spend 10 hours trying to solve the puzzle. The AI could solve the puzzle for you. And not only could it solve it, it could tell you if it was a unique solution, how many moves were in the solution, etc. I've also started getting into a little bit of procedural content generation in my research, but we'll have an entire section, like 3 or 4 lectures on procedural content generation in the course. So that's it for the presentation. The last thing that I want to do is really quickly go over the course schedule again, okay? So this is going to be the thing that you look at probably most during the term, okay? So what we just did was the course intro and syllabus. Next class, I will be giving an introduction to C++. If you did Computer Science 4300 with me, so let me just go over here and look at 4300. Okay, this is the playlist for that course. So the second lecture in that course was an introduction to C++. This course here, this class, is going to be the same as that lecture. Okay, I'll change it up a little bit, but this intro to C++ will tell you all you need to know to get assignment 1 working. Now, there was another lecture on C++ in 4300. It was on C++ memory, stack allocating memory, heap allocating memory, pointers, more low-level stuff like that. We won't necessarily need that for this course, okay? But that lecture is there if you want to go look at it. So that's why I'm not including it in this course, because I want more AI-related stuff and less C++-related stuff, okay? So someone asked if assignment 1 is up yet. It is not up yet. And it's not up for a good reason. And I'll get more into that when I release assignment 1 on that Tuesday. Okay. The reason for that is one of the reasons is I don't want to give it out early because some people have a huge advantage on the C++, and so I don't want those advantaged people to get more time to work on the assignment. I want to be fair with everyone no matter what, okay? So after I do C++, I will release the assignment. The next class, we'll go over a little bit of 2D math, stuff that we covered in 4300. I will talk about Visual Studio, okay, because Visual Studio is, I give out Visual Studio projects for all of my assignments. And so like how you use Visual Studio, how to do debugging, what the options are and stuff like that. And then we will also give out and explain assignment 1. Don't worry, I will also go over how you compile and run things for assignments in the other operating systems as well, and all of these instructions are here as well, okay? So if you want to, you can go set this up on your system sooner rather than later, just that the assignment files aren't available yet. Okay, so if anyone has any questions, feel free to type them in the chat and I will answer them. But for now, what I'm going to do is at the end of every class, and I'll say this for now, but I won't in the future, I stop the local recording, okay? And I continue going on Twitch for a little bit. And what I can do then is, and I'll go like raid somebody on Twitch or whatever, which is really fun. But for now, I'm going to stop this recording. So thank you all for tuning in to the first lecture. I hope you enjoyed it, and I think the course is going to be really, really fun. And don't worry, we will get into all the details of the assignment and the project as the course goes on. So if you're on D2L, so if you are a student of the course, please go sign up for the Discord server if you're not already, because that is where a lot of the communication will go. All right. Thanks for tuning in.